Like it's actually more
But welcome everyone to TEDI Talk. Apologies on the slight IT issue there. We are today going to be looking at the TEDI Talk, releasing architectural freedom while simply improving thermal performance. So hopefully today you'll agree that we've got an excellent panel of experts here in the field to talk through and get some debate going on this. Feel free to ask questions in the comments box, or if you're on the Zoom, to ask via the chat. On behalf of Build, welcome. My name is Nick Horton, and our panelists here. I'll start with perhaps Andrew Peel. You can start by introducing yourself, and we'll go and get a bit of an understanding before we jump into the first question. Over to you, Andrew.
Great, thanks, Nick. Yeah, Andrew Peel from Peel Passivhaus Consulting. Basically a Passivhaus consultant, building certifier, and trainer. Been involved with Passivhaus for over 15 years, starting actually in Germany. I've also worked in the UK as well as here in Canada. And yeah, we work on projects of all sorts of sizes and types, from your small single family home to high-rise buildings and all sorts of interesting non-residential buildings, car dealership, production facility. Yeah, and I'm excited to be here. So thanks, Nick.
Thank you, Andrew. Maureen.
Hi, everybody. I'm Maureen Sanchez. I work with RDH Building Science. So we're energy consultants and building closure specialists. I lead the Passivhaus services for North America for RDH. So that gets us to see different regions and different types of projects. So that's quite exciting. And same as Andrew, made it to Canada for a small detour from France and the UK, but yeah, Toronto it is right now. So thank you for having me.
Thank you very much. Rob.
Hi guys, my name is Rob Corwin. I am a partner and project director with Bluescape Construction Management. We are a mid to high-rise construction manager, focusing specifically in the GTA market. Build projects anywhere from 8-9 stories up to 50 to 60 stories. Anything from purpose-based built rental to specific condominium to multi-use projects with high commercial components. Been in the industry about 15 years, and yeah, it's kind of who we are and who I am. And thank you, Nick and Murray, for having us today. Looking forward to it.
Thank you, Rob. Andrew.
Good morning, everyone. My name is Andrew Geldard. I'm a senior associate / design director at BDP Quadrangle in Toronto. I'm both the licensed architect in the UK and also Ontario as well. And I recently achieved my Passivhaus certification as a designer at the end of last year. So I'm in good company here. So primarily focus on the multi-unit residential sector within Toronto. Similar to Rob, we build very mid-rise to high-rise buildings all over the GTA, and that's about it.
Thank you very much. And last but not least, Murray.
Yeah, thank you very much. My name is Murray Hone. I am the North American business development manager of Sapphire Balconies. So I've been in the construction industry since my 20s. I guess that was kind of my first major career, and specifically in the Division 7, insulation, cladding, roofing, that kind of exterior side of it. And most recently, for the past almost a year and a half now, with Sapphire, and really trying to push the thermally broken, thermal efficient balcony options to the North American market.
Thank you. So starting off with obviously the context of why we're here today is very much about TEDI and getting that balance between thermal and between the architectural freedom on buildings. The context that we'll look at today is predominantly going to be high-rise, but I guess, Andrew Peel, if we just perhaps start off by looking at the whole reason, the step codes, and the changes that's bringing in, and how that's making things more onerous on the building. How, in your opinion, is this affecting both the design and the construction of projects?
I think we're I mean, so Passivhaus fundamentally, to do it effectively, we need to have a collaborative team effort, right? So we're starting to see working with some teams that may not traditionally work in such capacity, they're realizing, okay, they need to really start to do, if they're going to do this cost effectively, they really need to start to collaborate more up front as a whole design team. So I think that's kind of gradual, but a fundamental shift that's happening.
Thank you. If we perhaps move to the other Andrew and to get another point from more the design aspect first, and we'll come on to the construction aspect.
Yeah, so with the step code increases, especially in Toronto with the new TGS versions that have come into practice, I think it was the May last year, TGS Toronto Green Standard version 4 came into being. There was a big reduction in the TEDI number, and as a result of that, it is influencing how we approach the design of buildings. And one of the things we're pressing upon our teams, and something we've been doing prior to that even, was really focusing on lowering the window to wall ratio of the building from collaborating with like energy modelers similar to RDH. That does have a big impact on the TEDI number. Even a small decrease from 1% can have an impact. So we're targeting around 40%. We usually find of opaque assembly, 40% glass to 60% opaque assembly for the wall. So that's a good foundation to build upon. There are other things we focus on as well, like minimizing thermal bridging, minimizing balcony design, and then increasing the overall effectiveness of the R-value in the wall assembly as well. And then that, in combination with mechanical systems, can help us get a long way to reach the TED number.
Thank you very much. Marie, what's your thoughts on this one?
Just adding to what Andrew and Andrew just said, but the TEDI numbers, the targets are getting more and more stringent, and even if we have quite decreased with the Toronto Green Standard version 4 last year, it's still not the end goal. We still have 2 more steps to go to get to our goal for 2030, which will now be implemented actually in 2028 for private buildings, 2025 for public buildings, so almost tomorrow, right? Because 2023 is already here. And so that pushes to get to the very low TEDIs, which is our end goal. It means that you cannot leave any stone unturned, right? We have to look at every single thing. Yes, it is opaque, but it's also window to wall ratio, glazing performance, mechanical system. It's not, how to say that? It's not like a down menu that you can pick and choose anymore. It probably needs you to look at absolutely everything and optimize that from day one. And I want to highlight what Andrew Bill just said. We know how to do this. We do have the technology, and one of the key elements that we're hearing right now is that it always costs more. And we don't believe it has to cost more if that energy performance is embedded in the design from day one. But for us to get there, you need every single discipline, and I'm including, electrical, mechanical, structural, as well as architectural, to understand what is the impact of each of their design decisions onto that overall TEDI that we're trying to manage and really keep at bay into a very small moment. So different skill set and a much more collaborative environment, that's for sure.
Sure. So Rob, from a construction point of view, what are the changes you're seeing already or foreseeing from the more recent steps and the ones which are yet to come?
Yeah, so I think my other colleagues kind of touched on all of them as to what I'm seeing in the industry. I think Andrew spoke to window wall ratios, just the overall increase and amount of insulation in the exterior envelope. Marine spoke to the impact of mechanical electrical systems. We're seeing a massive uptake in geothermal systems as well, so much due to the financial models that go around them and how successful they can be. That solution fits some projects, it doesn't fit all. It's not a one-size solution. But I think overall, if you take the TEDI number as the driving factor, like for me, what it impacts is it's just changing building systems. Our mechanical systems, electrical systems are changing, envelope is changing, and it's all being driven by those systems that are changing. So then it becomes a question of, well, how do you execute on that and how do you deliver on that? Maureen spoke to cost, and the reality is in certain projects at the moment, particularly condos, the long-term viability of energy isn't really a factor because the developer's not going to see the return on it. Whereas other projects, purpose-built rentals, absolutely will be. And certainly probably more government-based projects as well will care about that. And then the other thing, like implementation, is just, you said, well, the technology is out there, and we'll absolutely agree with that. The trade base isn't there yet. So it is about, at the moment for me, it's about picking selective contractors, working strategically with people who can actually execute on these things, so that you can deliver a successful project. And until that kind of wider market and the overall like critical mass of the market gets there, where these things that we all need as a society and these systems are just commonplace.
Sure. And so, Murray, moving on to the balcony context, and how does that affect balconies and both the design and the actual construction side of things, and where's the interface with TEDI?
Yeah, no, that's all great. So I think it's a balcony aspect, and I get you can relate it to costs. Very typically when we come and I'm proposing a thermally broken or a lightweight thermally broken system, costs always get brought up. And I think the whole point with TEDI and thinking of it in larger is it's not necessarily an apples to apples, money to money cost, but it's an opportunity to look holistically at how it is going to perform, how it's going to affect the R value of the wall, how it's going to actually affect a full building's performance. So I kind of always say, like, I'm not here to sell you a balcony, but I'd rather help you change the way you design or change the way you think of design of buildings. So again, with everyone said, it's that full collaborative approach. It's showing what a balcony can do, how it can affect things like the superstructure, like the R value, like all of those other things, with the end goal of meeting budgets and targets.
Sure, and we've actually had a question come in talking about what the role of window to wall ratio is in the TEDI ratings. Now, I can't remember which one of you mentioned this, but Andrew, it may have been you in BDP. What's your thoughts on this one?
So why does it affect the TEDI? Well, it's because, to me, we talk a lot about thermally breaking balconies, which is a good thing as well. However, one of the most impactful things I've realized from experience is focusing on the window perimeter detail when it connects to the opaque assembly, and by making sure that is tight, as thermally broken as possible, be with the mullion design, thinking about what the mullion is made of, that really does have a big effect on the TEDI number. So that then ties into why the window to wall ratio is kind of key as well, because it affects the amount of window perimeter glazing number. Basically, if you measure the perimeter of all the glazing, if the ratio is higher, then you're going to have a bigger number. So and if you want to achieve passive house levels in like multi-unit residential design, you'd be looking at like a 30% number, and there's very few examples yet done in Canada. There are a few. I think there's one in Hamilton, and but you can, it's something to pay attention to, and obviously it affects the design of the building as well. So that's why it's important.
Anyone else got a thought on this particular topic of wall to window ratio, and perhaps kind of where that might perhaps become something quite restrictive on your architectural freedom?
Well, I can maybe add a knock-on effect as well of large glazed areas is the impact on mechanical systems and cooling loads. And this is a sort of something that we're really deeply exploring, because as we shift to electrify buildings, go from your boiler chiller typical solution to different sorts of heat pumps, we know that comes at a price tag, right? But if we're sizing those systems in a traditional means and according to large window wall ratios, then we see much higher capacity than if we're actually bringing bringing that window wall ratio down, we're limiting the solar gain, which is the biggest driver for cooling loads in these buildings, right? I mean, pretty much in any most buildings, particularly this type of building, this multi-family, high rise or mid rise. So if we can really limit that solar gain, we can really help drive down those cooling loads, and that's what's really driving mechanical system design.
Nick was going to a little bit more to that as well. So definitely a good point on the cooling load. In terms of the impact of the window to wall ratio, back to your original question, there's no denying that the window to wall ratio is definitely one of the key levers onto the space heating, the TEDI demand of your building, right? But you still have some flexibility. It doesn't take away, it's not because we're reducing it, but you're taking away your freedom, right? It's more managing your energy budget. So we design a lot of passive houses here around the Toronto area, and we probably work on mid-rise with a window to wall ratio around 20%, if not a little bit lower, all the way to high rises where they can get up to 40%, I would say. So that's the range, but the 40% is still the exception. I just want to be clear. However, as energy consultants, we never come in to say your window to wall ratio should be no more than X. Like, that's not the approach we take. We just explain that similarly to your financial budget, if you know how much money you have, you design accordingly to make it fit within your budget. Same thing with the TEDI. We know how much energy we get to spend throughout all our design items: ventilation, opaque enclosure, windows, right? And so if we have a design team, a client team that is forcing, for example, to increase the window to wall ratio compared to the typology we're working with, then you simply have to balance it somewhere else. So we have that flexibility, but what is new to the industry is that you do need that budget management on the side. You cannot have just flexibility and no budget management, right? It doesn't work financially. Same thing with the TEDI, it doesn't work this way. So it's really that delicate balance exercise and understanding how each design lever gets to move your energy model, and therefore your predicted TEDI.
This is really interesting point you make. Then you referred to them being one of the big levers there. What are things that are critical to actually moving that needle to affect achieving a lower TEDI rating? Rob, have you got any thoughts on this one?
I think in terms of moving the design lever, I think my colleagues could probably speak a lot more to that. A lot of this is driven up front as a design exercise, and I would advocate that you always have to think of the practical implications on site. Just talking about the window wall ratio, maintaining that in a single system, right? So in Toronto, what we would typically see is your towers are window wall, and whether you move between clear vision and a solid wall, it's a spandrel panel, but it's all contained within one system. So just advocacy of, understand what the design items are and how they're, as Marine kind of talks about, the design levers, how those design levers pull in the practical construction levers. But in terms of what else affects TEDI, I think the other panelists are, from a design perspective, are much better suited to maybe field that question.
Andrew Peel, any thoughts on this?
Yeah, well, actually, one thing that really is impacted by from the construction side is air tightness, and actually air tightness. No matter what climate you're in, what type of building, it has an impact. Right? There's other measures that there's climates where we don't need heat recovery because they're milder, but air tightness, they've established that it works everywhere and it's important to do everywhere. And we like, unlike a passive window, we can go and order it from a factory. Right, gets shipped. We know how it's going to perform. Air tightness, we can specify all these great, wonderful materials and spend a lot more money or not, right? Depending on what materials we're choosing. But at the end of the day, we can only deliver an airtight building through the construction process, right? So I think that's where on the construction side, there can be a big impact.
Could I add a point to that as well? Like what else you could focus on? And I think Marine focused on it is if you, for example, spec triple glazed windows, that would help massively in achieving a lower TEDI number. Your embodied carbon number would take a bit of a hit, but there's, I think we're still working through this balancing of both the embodied carbon budget and operational carbon budget. But yeah, your windows are the kind of weakest link in the facade when you remove it from the opaque assembly. So there's a triple glazing, and then really understanding the R value, effective R value of your envelope system. And there's some prefabricated systems out there where the R value, effective R value, is up in the high R20s, which is a very good number. However, if you can establish a good number to focus on early on as a kind of a goal within the design team, it can focus everyone's attention. And we're trying to do that on projects as well. But I think we're still we're in the beginnings of this because of the step code changes. So it'll be really interesting to see how designs evolve and also how construction trade skills evolve in tandem with that. So.
Marina, I think you were wanting to add a point there as well.
Just thinking out loud, we went through most of the principles. I guess the last two to touch on ventilate. Sorry, maybe three. We didn't say exactly thermal bridging, but now that you're improving the performance of all the other elements, thermal bridging becomes more prominent. So we have to look after them, and Sapphire with the balconies play a big role onto that element in particular. Ventilation, of course, because ventilation with heat recovery in our climate makes a big difference onto our TEDI. The final item I just wanted to bring, because it's not mentioned, I think, often enough, is the form of your building to start with, the compactness of it, because this is something that most of us at the table, maybe Andrew at BDB, you get to have more of an influence, but for the rest of us, the form and the compactness, the massing and the orientation of the building tends to be set when maybe we join the design table. And what I guess design teams are not fully realizing yet is that through that massing and that orientation, you've already spent part of the energy budget that you get, right? And so sometimes the way it has been designed, the way the massing has been developed, means that you will have to work a little bit harder somewhere else. And that's like, we need the industry to become more aware of that so that they're not spending their energy budget where they don't want it to. It's really important to prioritize where you want to spend it. If window to wall ratio is where you want to put, an emphasis, then go for that. But everybody needs to be aware where it gets spent. And that's probably the only portion where people don't quite realize that some of their budget already got taken away from them.
Yeah, and I'd add a point on the form there. What I found an encouraging sign is, you may know in Toronto or the GTA, there's this requirement of the angular plane along streets, and as a result of that, you end up with a lot of wedding cake buildings, we describe them, where they step back to fall under the angular plane. But as a result of that form, you increase the surface area of the envelope, and then to the volume inside. So it makes it inefficient in that regard. But what is an encouraging sign from the city and municipalities is to focus more on a simpler form and more efficient form that would perform better thermally, but also, in my opinion, create better spaces to live in and also be easier to build, just without all the structural gymnastics you may need to step buildings down. So be interesting to see.
I guess, Rob, you would agree to that, huh?
Yeah. Mm-hmm.
And if you're sitting there as a developer or a client looking at this and you're not very familiar with this kind of approach, where should you go to actually understand a bit more about how the effects are and learn a bit more about that as a personal thing?
Is how form affects that, or what the TEDI actually is, or no?
I guess the green standard explains TEDI, and there's a few links within that.
I know within Toronto, you can go to the city's website and they have a pretty well described what the Toronto Green Standard is, and each municipality has that. Unfortunately, right now, each municipality is different. Toronto is leading the way. However, if you go to Mississauga, it's not as stringent. I think they will move in that direction, but right now, it is a frustration that you leave, cross over one street, and it's why is the building different on that side of the street than the other? But something we're doing internally as well. We have an internal green team where we kind of develop these. We develop information to aid everybody within the company, because a lot of these things are hard to understand and get your head around just on your own, never mind put them in a way you can present to, say, a client or a contractor and make sense at the end of the day as well. So it's we do a lot of that in-house to help and train our staff, but there's also a wealth of information out there as well. But probably the first place to go would be the City of Toronto's website to find out more, for sure.
Any thoughts on this, Marie?
And add to it as well, but there's a lot of training available out there to help with these key principles of high performance design and high performance build designs. You know, so yeah, I would just encourage everybody to look at the resources. Like Passive House Canada is one of them. Andrew has also training directly on his website. So it's just the information is out there. Sorry, the British Columbia Energy Step Code. They're again slightly ahead of us because they've been developing some of that training for a while as well. And what I want to highlight is that, you know, if you're working with, let's say, a Toronto Green Standard Tier 4 building, which is the end goal, or a passive house building, or a CAGBC zero carbon building, even if these have all different names, they're all simply different flavors of high performance buildings, and the design principles remain the same. You still have to work on having a tight building, on really good glazing, on, you know, performing enclosure, good ventilation system. Like, it's all the same. So what I would encourage people to do is go grab the training that enables you to embed high performance to your practice, and don't think that the training is particular to one flavor or the other. No matter what you do, this is going to empower you deliver and be more comfortable delivering the buildings of tomorrow, because we're going there no matter what. So just really important to get comfortable, get that common vocabulary that we all need to have on the team to understand how the energy budget gets spent, and then be able to manage it. That's all, right? Like that's at the end of the day the end goal. And I don't know, Rob, would you add anything to this? Because clearly we need to know how to manage it as a design exercise, but then we still give that budget almost already spent, and you still have that duty of care to maintain that budget and deliver as predicted during construction. So I think that learning curve also applies to the construction teams, right?
Yeah, absolutely. I mean, that's a loaded point you leave me with there, but how you get to spend this budget through the course of construction. And I really like that analogy. But if you go back to the root question that Nick had, which was, you know, where do you go to learn about this if you're a developer, you're an owner sitting on this call? For me, it's about the team. It's the project team, and how that gets assembled and who's part of that. I've got 3 colleagues on this call who are infinitely more well-versed in this than I am. And I think you would learn as an owner or a developer a lot more from speaking to these type of people than you would just simply pulling out TGS and trying to understand it. So for me, you know, to that root question, it's engage a team early, it's engage your energy modeler early, make sure your architect competent in this field, and have reasonable professional conversations with them. But the one thing that I would caution in those conversations is it's always a trade-off. As much as you talk spending, you know, your energy budget, the project's got to remain viable. And in all of these conversations, you know, you're talking about what systems you can deploy to achieve that project viability. It's cost viability is really the holy grail of it all. And without that, nothing moves forward. So just any conversation with your team, and which is important, has to always be in that context.
Thanks, Rob. Murray, any thoughts on this? We've obviously touched on briefly on terms and so on, but in terms of moving the needle from a balcony point of view, or any learnings on that, any thoughts on this?
I think as the, let's say, architecturally, I think I mentioned this in our discussion the other day, but as the energy requirements are kind of moving, let's say moving forward, the step codes are going, I think there's going to be a little bit of a requirement for collaboration in that where a project might have been completely architectural driven, almost completely architectural driven as far as what would be there and the vision or what would be left behind. Now all of these factors, it is a give and take, and exactly like it's a pull, it's a lever. So I think the simple form building, the simple form buildings are the most viable, and I've kind of described building on simple forms kind of with I call it the Mr. Potato Head principle, as far as being able to add profiles, being able to add shapes, dynamic aesthetics to a building that still retains a very simple form. And I see kind of construction starting to trend that way, and without as many jigs and jogs, simpler forms, and with kind of lighter weight attachments, and I see us trending towards that side. So a balcony for me, kind of everyone has several of us have funky glasses. I see a building that's kind of what a balcony is just going to be a pair of glasses that you can take on, and at the end of it you can take it on and put on another pair, and I can see modular buildings being accessorized that way, and I think it's going to be a cool architectural styling movement in that sense.
Interesting, Marian, thanks for that. Moving the conversation on slightly, and we talked about kind of engaging energy consultants and have been quite critical for understanding and learning in this process. What stage is right for engaging with energy consultants? Rob, perhaps we start with you on this one.
As early as possible. You've got to, Maureen spoke about the point where, if she gets involved and the building's already orientated, maybe that's too late. And one thing I would say in all of that, there can be, as much as everybody loves the word early engagement and early collaboration, it can be too early. So maybe I'd rephrase that to the words timely engagement. But certainly during schematic design, when you're looking at just overall project viability, an initial conversation is certainly worth it. For me, the energy modelers have become more and more involved. 10 years ago, it was a rubber stamp exercise just as part of your building permit application. Now it's not. It's fundamentally not. But some of the concerns that I could see, people in my shoes or clients having as well, spending fees on that, and is it timely to engage in that? But I would feel that an initial conversation, which is probably peanuts in a dollar or peanuts in the overall bucket of a project, would deliver tremendous value before you move into kind of a full-fledged review. Schematic design is probably the point for me where you need to start thinking about it.
I could jump in maybe. I think where we need to move, and we're starting to work on this, is getting more almost real-time feedback for architects on the energy performance. Almost, to Marine's point about the energy budget, that they get to see the energy budget as they're designing. And I kind of want to find a way of not eliminating energy modelers, but making them using them in more effective ways. Not building all these separate models or whatever, but how can we integrate it into the workflow so architects are using their design tools to design the building, but they're getting the feedback on the energy performance, and the energy modelers are there to help guide the process. And so I think there's a great opportunity. And he said we're there's a few of us that are kind of trying to work on that kind of thing. Because that's it. I think to Rob's point about, there could be a lot of extra costs if you're doing a lot of design iterations and you're getting somebody to update an energy model 10 times. Like, there's a big expense to that, right? And a lot of that is not productive work. It's like changing your window wall ratios, all that. Whereas if that's happening in real time with the architect as they're modeling, there could be a lot more effectiveness to the process.
Nick, I was going to add a little bit on that as well. With both what Andrew and Rob just said, I would rephrase it with, you want as early, an engagement as early as possible. So even concept design. However, what Andrew and Rob are both talking about is you don't need an energy model from day one. If you have an experienced team, then you can talk qualitatively about all these design aspects. So you want the engagement at concept. As soon as somebody's at the table, I believe you should also have an energy modeler, not for intensive work, but just for guiding, because we need to maximize building performance and minimize cost. And for any client to get this double optimization, it has to start from day one. If the building has been designed in a certain way and you're trying to make it something else, changing something that was intended for something else will, no matter what, cost you more time or more money, or lose the performance target that we had. So it's that really early engagement, but on qualitative aspect to make sure that we're guiding the team as well as possible. And then first energy model, I think Robert right, definitely around schematic design. You know, if you are working with experienced teams, you probably don't need to trigger that much before, but you need that collaboration from day one. You need to be able to embed energy and carbon management at the core, right?
A really interesting point there. So it depends kind of what you're trying to achieve, but it's certainly a role from an early stage. Just it depends on the scope of that. Andrew, it looks like you're trying to get in there as well.
Thank you, Nick. Yeah, no, early engagement is key, and something we do is establish goals regarding sustainability with the design team, and that could be a focus on, you know, like zero carbon level 2 or something like that, or a low TEDI number, low EUI number, net zero, for example. And just even establishing the goals is kind of key. But even if you fail in achieving some of them or all of them, but you get close to them, that's still a good thing, in my opinion. So having that kind of focus early on, and then kind of building upon that, and then understanding how the architecture has to adapt to achieve these goals, and then bringing in energy modelers to kind of iterate on these designs, but knowing that you've created a good foundation to build upon based on your choices of form, window to wall ratio, and your envelope system, you'll probably be in a good place in achieving all of your goals, or at least some of them. Something we've debated internally is, do we start hiring energy modelers in-house just so we can go through this process, or but we haven't yet. But something we have done is trained our staff. Myself and 11 other people became Passive House certified last year. So it's like building that wealth of knowledge within a company is kind of key as well. So it kind of passively can, and actively, influence the way we build buildings as well. So we're really hyper focused on this right now. So
brilliant. Looks like we've had a question come in as well. Kind of moving the conversation on a little bit again, but relative to what we've been talking about, is where the lead and passive house really interface with the whole TEDI question. And to start with you, perhaps. Sorry, Andrew Peel.
Okay. Well, I guess lead isn't defined in a way, it like doesn't have a TEDI target. It's more relative performance over a baseline. So there's not a direct comparison. Certainly you get lead buildings that perform from a high energy efficiency perspective. Other projects don't, where it really depends how it's set up, what kind of energy performance is expected. But yeah, they're kind of two fundamentally different ways of approaching the energy analysis of a building.
So obviously, there's aspects which affect your lead score, like air tightness, as well as related topics, isn't there? Who else would like to answer this one?
I can speak to, so with the TEDI number specifically, that is a requirement from the Toronto Green Standard. It's a specific number. I think the mandatory requirement now is 50, and it gets lower if you go to the higher tiers. Like I think tier 3 is like in the 30s. But from my passive house training, there's no TEDI number requirement in that. You'll obviously achieve a very low TEDI number because you have to hit the EUI, I think it's 15 kilowatts per hour per year that you can't go over to kind of heat your building. So you would achieve a low TEDI number by having to hit that certification requirement for passive house. So there's no direct connection I may be wrong in this, with lead, but I think if you focused on a low TEDI number, you'll be doing achieving a high probably LEED score as well if you want to pursue that certification, even though there are differences in that, in just from my experience.
The Toronto Green Standard does spell out some of those passive measures anyway. Very, any thoughts on this?
Maybe just summarizing. So what Andrew Peel was talking about is LEED at its core is a sustainability standard, not an operational energy standard. So this is not to be confused. And so when we talk about performance of building really varying, it's really related to the fact that you can achieve LEED certification through various measures. And if you focus on, other measures than energy efficiency, then you're not going to get anywhere close to Passive House and TGS higher tiers, right? If you do, you might. So I would describe Passive House and low buildings with low TEDIs as a really good first steps to get really good energy performance, which definitely helps you get the energy credits out of the LEED standard, which is a much broader sustainability standard. Regarding Passive House, so Passive House does have a TEDI requirement. We call it slightly differently. It's that space heating demand, but it is that 15 kilowatt hour per square meter per year of energy consumption to maintain your building. Sorry, not energy consumption, but energy demand to keep your building comfortable during each season. So this is what relates to your TEDI, and this is very much aligned with the end goal of the Toronto Green Standard, with the end goal of the BC Energy Step Code. So all these final steps are almost aligned as far as we're concerned. So, and as I said before, getting to low TEDIs, which means looking at each aspect of your design, right? Opaque enclosure, glazing, ventilation, infiltration, and all of that. This is core to getting high performance buildings and the buildings of tomorrow. So no matter which flavor you're going to go with, these principles are going to be what's going to be embedded based on, our codes and standards really getting more stringent as we go along to make a dent in that climate emergency that we're trying to address. So.
That's a really interesting summary and very compact, but quite a detailed subject as well. So thanks. Murray, we've just obviously touched on thermal, we touched on embodied carbon and so on. What are your thoughts around kind of the role of balconies and the choices you're making in balconies and how they affect thermal and then carbon?
Yeah, no, great topic. I think my let's say my main goal or topic is the carbon reduction, especially in comparison to what North American is conventionally built. Their condos, which is just concrete balconies. So talking about just not having that at all, there is that severe let's say a carbon or concrete reduction, the ability to lighten the overall weight or the mass of what's hanging off, also can affect the superstructure, the overall lightweight. So very often, high performance, you think of a high performance vehicle, it's lightweight, it's compact, and very typically, I think we've built kind of like a, not to say garbage trucks, but we've built something really heavy and clunky, and so yeah, I think kind of better material selection, lighter weight, lighter weight options. Really reduces the amount of concrete, the amount of steel on the balconies themselves, and that can actually transfer, like I said, into the building itself. So all for the sake of carbon reduction.
You talked about the mass there, but also presumably the structure of the building and the structure connected back into the balcony, reducing the amount of thermal bridging and all at those points.
Absolutely.
So if we're talking more generally then about this balance between embodied carbon and reducing thermal performance, it was touched on about the triple glazed windows and so on, but have any of you got a thought around kind of are we? Is this a seesaw, or is it, or the one certain aspects of it which actually help both, other than the balcony side of things Murray just talked about?
I can speak first. It's something that you probably don't really see in the building, but one of the biggest things you can do to help your embodied carbon on a multi-unit residential building is eliminate the parking structure underground. That's one of the biggest things you can do. Obviously, that comes with other issues and concerns, but that's one of the first things you should look at and minimize or eliminate entirely. And some buildings like downtown Toronto are being built with no parking structure there because of and the city have relaxed the requirements, the minimums and maximums have been removed. But then once you've done that, obviously then the structural system of the building is key, and eliminating massive transfer slabs through concrete is the next step. And what I said earlier about eliminating these kind of wedding caking, stepping back buildings helps in that, because you don't have to transfer structure horizontally through the building. You can align most of it vertically, which is a good thing. And then it does become a bit of a trade-off where you need to start looking at what your envelope system is made of. And from our own study, we found aluminum is one of the worst offenders when it comes to embodied carbon. And however, that is pretty much in every facade system right now. So I don't think when we start looking at, say, precast concrete, which you might think is even worse because of how it's made, it actually falls within a better ratio when you compare its embodied carbon to performance score from our own study. But I don't think we've really solved that, in my opinion, yet, and we're still kind of working through that. But with the tools of like one-click LCA, which we're starting to use to analyze buildings, this will help us inform how we move forward because of our understanding and the data we're collecting on certain things. But it requires everybody to be doing this, so we all kind of create this kind of group knowledge and then understand and move forward together, in my opinion. So
it's an interesting point you make there. I think probably the key point to note on a lot of this as well, especially with LCA, I've had quite a lot of experience within space with them, but certainly the tonnage of aluminium is very bad compared to a ton of concrete. But obviously the volume of a ton of aluminium goes a lot further than a ton of concrete, which makes a big difference to the overall embodied carbon number.
So Nick, I was just going to add exactly to both of your points. We do a lot of LCAs, the life cycle analysis here, within our energy team. And I have to say that even if Andrew or your point are bang on in terms of, what are the easy tickets that you can do to make a difference, I want to say that you still want to back this up with your calculation. Because I totally agree, Andrew. I think you're 100% right. I think when we fine tune, triple glazing versus double glazing, or a bit more insulation versus less insulation, you have to look at the entire life cycle, right? Because maybe a little bit more of embodied carbon because you are buying more insulation would save it, X amount of times over its entire life cycle. And I think that we got even if we know what are the key levers again, I think you get surprised because you need, for example, very little aluminum for some of the systems that you're working with. So maybe that, it allows you to have less of it because it's very robust. So there's so many, how to say that, so many perspectives that you have to bring back that you do want to go back to your calculations to help, to use that LCA model to help the design team make decisions. The same way we're now agreeing that we need the energy model to help the design team make decisions on operational carbon rather than embodied carbon. So just highlighting that there's some easy portions, but then you want to do the calculations that we learn more as an industry. We share what we found, and then we start creating better rules of thumbs or better, recipes for, if you want a low embodied and low operational carbon, do this and you'll be 95% good, But Andrew, you're right, we're not quite there yet. the industry needs that to mature a little bit before we get that comfortable.
Agree, and that whole life cycle analysis is so important for the overall, because I guess as a simple takeaway for attendees is that if you can get products which improve the embodied carbon and improve the performance during the whole building, if you like, that is a win-win. But you need to look at that kind of balance. In some projects, embodied carbon will be very, very important. In other ones, it will actually be the operational carbon, and the board life cycle is much more important than the embodied carbon study. But today's topic isn't embodied carbon. I'm going to move the conversation on a little bit back to the world of TEDI. But what can Canada learn from other markets in view of actually reducing and meeting those enhanced step codes as they come? Perhaps we'll start with Andrew Peel.
So what can we learn from other countries who have implemented step codes?
I think the question is more out kind of, similar to what you're saying there, but more kind of for the Toronto green standards and other step codes around Canada, and what can we use, and I guess probably both in terms of technology and knowledge from other marketplaces.
Well, I think we're seeing this in real time. Like if a jurisdiction can create a step code, and they clearly define to the industry, this is where we're heading. Hey, in 10 years' time, this is where you need to be. We see the early adopters, the progressive developers, building owners start to do that early ahead of the game, because they know, hey, this is where we're going. We're going to invest, right? And we even saw that, Marine, you and I were in the UK, right, before, and where there was the early zero carbon policy in the mid 2000s, which started to have some of the big builders in the country start to invest and say, how do we work? How do we figure this out, right? So I think just signaling to the industry through concrete policy, this is where we're going, is one of the biggest steps we can do as an industry, because industry will naturally start to follow in line. Basically, there'll always be stragglers and people, kick and scream. But if government can be really clear and commit and stay committed, not just develop a policy and pass it, but keep it in place until the end game, because we've seen it where in countries where they've implemented the policy and then there's a policy change, typically a government change, and then it gets retracted and then it just disrupts things. So we need to develop, implement policy and keep committed to it.
Perhaps I've got time for one more question before we start drawing to a close. But Rob, tell us a little bit about your experience in terms of construction and a system which might be great from a point of view of thermal modelling and so on. What challenges need to be considered in actually modelling the success of a structure, both from a successful point of view of thermal and the construction aspects?
I think it comes back to what I said earlier, which is the team, and just establishing the project team. Both your design team, the ownership groups and stakeholders, as well as your construction team and supply chain that's actually going to be able to execute on it. Andrew just spoke about, government policy creating like early adopters. And if you take, given the conversation that we're having, the Sapphire system, you need a team that's competent, professional, patient, that can ask questions that need to be asked at the appropriate times in terms of like feasibility and how these new technologies will assist us. But also, understand that, if I'm talking to like a Murray about, putting a balcony in a project, well, what's his objectives in this? He understanding like what each party's objective is in this situation, being able to knit that together as a team. And if you can do that as a balance, understand that ultimately what you're trying to do is deliver a viable project, that for me is probably the biggest success point and biggest issue that we've had in terms of some of these things. And it's very qualitative. It's a very personal item. But that's it. I think if you can knit together a competent team, I think you're massively 10 steps towards success.
Excellent. Thank you very much for that. So I'd like to thank everyone on the panel for sharing their insights and on kind of balancing thermal performance and architectural freedom. Before we conclude there, could we perhaps start by going through each one of us, giving you a 20-second takeaway for the audience, please. Marie, perhaps start with yourself.
Go ahead. Yeah. I wasn't sure if it was you or me.
Marie, sorry, RDH.
Okay, sure. I'll start then. Okay, so my key takeaways based on today's discussion and, just like, again, 15 years of experience moving us this way, delivering high performance buildings will always be a team sport. So it goes back to Rob's point. We won't achieve it if not every single discipline and people at the table, be it client, design, and construction team, doesn't understand where we're trying to go and why we're doing it. Okay, so first, it's a team sport. The second point, I guess, is that I don't necessarily see it as a loss in flexibility or freedom. I admit I am not the architect, so it might be easier for me to say that, but I think that if we start bringing that energy budget understanding and management at the core of the way we design, we actually have enough flexibility to go for the top priorities, but it does ask us to really understand what we're after and prioritize what we want to see, because we can make that happen. It's just we might not be able to make the second half of our list. But trying to achieve so many objectives all at once, we can't keep designing the way we've done it before and think that we're going to get a different result, right? So based on that point, we need to change. And for us to change, this is the way. We still maintain flexibility, but we need to be more, more deliberate about what we want to see in the design and really focus on items. So to close it off, I guess I would say, I know we can do it. We have the experience, we have the expertise, we have the technology, the sapphire balconies and other type of, improvements. Like all these systems are just here to keep helping us achieve that, easier and easier. But at the core, I think we need to change the way we design buildings, the way we interact together. We need to change to really move towards that collaborative experience. Clearly on the design process, we talked a lot today, but Rob highlighted that as well. We need the construction manager to be there early to understand why these design decisions got made and how it impacts the budget. And then that knowledge has to be transferred not only to the GC, but to all your trades, all the sub-trades, to actually the people installing it. Because the best design in the world is worth nothing if it actually doesn't get installed. And I think that's the core of the challenge, the way I see it. So we can probably race to it, but it takes a bit more than just expertise and technology. We have to change our approach to buildings.
Thank you, Murray Hone.
Yeah, I'll again speak to the collaborative approach that I think is so necessary, even coming from, and Rob touched on it, even coming from myself representing a company that's manufacturing and selling a product. There needs to be the flexibility with our side in trying to let's say respect architectural aesthetics, trying to acknowledge real world budgets, and trying to help kind of make sure or understand how our product can interface with the and create or change the building's performance. So yeah, again, I think it's all a really important give and take. As we're all learning and as performance is improving in general, I think it's just going to continue to grow into a more open source collaborative style of construction and building.
Mary, Rob.
Okay, so 20 seconds. First thing I would say is understand your market is incredibly important. Not every project needs to be or can be the most highly thermal performing building. The base minimum of that is going to be set by government standards, and personally, I think that needs to increase. But that is ultimately going to have a knock on, at least in the medium term, on project affordability and housing affordability, and that's a huge issue. So all of this conversation it needs to be under in the bubble or in the frame of overall project financial viability. The ways you achieve this in the most reasonable possible fashion, again, is the team. The team is so important. And then also within that team, just understanding how you're going to execute on site, how these design requirements and these design decisions feed through to the actual bricks and mortar and glass and aluminum and concrete that ultimately gets built on site is hugely important.
Thank you very much, Rob. Andrew Peel.
I'm just going to pick up on the team, building the right team. I mean, from our experience, the most important ingredient in all the projects is attitude. If you bring a team together, even outside of not having experience, we've taken green teams, we've trained them up, but they've had all the team members had the right attitude, and we've delivered, passive house type projects, for a few percent more than conventional. So it's possible even without experience if you have the right team, the right commitment, right, and the right approach with a good collaborative, integrative design and construction process.
Thank you, Andrew. And last but not least, Andrew.
So my final point on that would be, I think a lot of has been said about doing things early, building the right team and sharing the right commitments, it's a design team, the client's vision. But just speaking as the architect, it's also, I think in a bubble, you could create the most beautiful building, best performing building in a bubble, and it would look amazing. But then actually get this built. So it's really having a good understanding of the systems that are available to you right now and what's coming. And then understanding, the advantages, limitations of that system, and then adapting that, into a beautiful building as well. So it can actually be built to Rob's point, in a economical way without and performing exceptionally from an energy standpoint as well. I think is marrying the two together is the key, and actually building these buildings. So I'm really excited about the future in this and seeing in the next 5 years how we'll actually do this. So so it's an exciting time.
Yeah, and certainly what I've been hearing throughout is the importance of getting that big picture feel, understanding the whole impact of one decision on another, but certainly engaging people early, talking and being collaborative in the way you approach things. Certainly, we look forward to meeting everyone again at the next virtual event. The next one for North America can be on the ResiBuild website, or follow us on LinkedIn to understand and see our updates. Our website address is www.resi.build. And again, thank you everyone for joining us today. Have a great rest of the day. We look forward to seeing you at the next event.
Thank you very much.
Thank you.
Thank you, everyone. Bye-bye.
Take care.